wealth. In which case, we're recording? Everything's good? Yeah, cool. Right.
Excellent.
So we've been discussing subjectivity versus objectivity in many of our shows recently, and Dr. Andrew Lampinen is a senior research scientist at DeepMind, and he thinks that symbols are subjective in the relativistic sense. Now, Dr. Lampinen completed his PhD in cognitive psychology at Stanford University. His background is in mathematics, physics, and machine learning. His research interests are in cognitive flexibility and generalization, and how these abilities are enabled by factors like language, memory, and embodiment. Andrew, with his co-authors, have just released a paper called Symbolic Behaviour in Artificial Intelligence. Now, Andrew led in the paper by saying that the human ability to use symbols has yet to be replicated in machines. He thinks that one of the key areas to bridge the gap here is considering how symbol meaning is established, and he strongly believes that it's the symbol users themselves who agree upon the symbol meaning, and that the use of symbols entails behaviours which coalesce agreements about their meaning, which in plain English means that symbols are defined by behaviours rather than their content. Now, Andrew thinks that mathematics, for example, is more than just symbolic manipulation. There's something extra, something fuzzy. How do you get intuition? How do you communicate it to others? Could it be partially socially constructed, for example? And I don't think Andrew means fuzzy and extra in a David Chalmers kind of hard problem of consciousness notion. He's referring more to its complexity and relativistic nature. Now, I already know at this point that my co-interviewer, Dr. Duggar, is foaming at the mouth. He's chomping on the bit that these forbidden utterances have been spoken, that they've left my lips. But it should at least make for a very interesting and lively discussion. Now, Andrew tweeted back in March that arguments saying that humans do X and this particular model doesn't do Y are flawed because the model might simply lack the right experience or the right knowledge assessment. It might be brittle. Anyway, Andrew, it's an absolute pleasure. Welcome to MLST.
Thank you so much for having me. I didn't realize my whole Twitter record was going to get reviewed here, so I might have to be careful what I say on Twitter in the future.
Hey, that's good. That's good advice for anyone at any time, right?
Very true.
Everyone has to read that book by John Ronson, You've Been Shamed, talking about the perils of Justine Sacco. Hashtag has Justine landed yet? But anyway, just to frame this up a little bit, in your paper, you invoke the so-called triadic relationship of meaning with symbols, right? Which means that you think that symbols are entities that mean something to someone. And this relativistic interpretation of symbols is in the philosophical motif or tradition of Wittgenstein. So Wittgenstein said that we should understand words not by the kind of content of the words, if you like, but indeed how the words are used. And this should be familiar to, folks that do machine learning. It's a very similar idea to recommendation or collaborative filtering, where we should infer what the meaning of a piece of content is by its affinity to others or how it's kind of, engaged with by others rather than the actual content of the thing. So we see this idea all over the place. I think the PageRank algorithm is another example. But if you don't mind, Andrew, could you, and first of all, I think let's make this as pedagogical as possible. So explain everything like we're five. Can you give us the elevator pitch for your symbolism paper?
Yeah, so I think the basic question we were trying to ask is what is necessary for getting the kinds of intelligent behavior that humans exhibit? I think that's what we all agree, regardless of what, computational principles we think need to implement it. A starting point for getting general intelligence is getting to the level of intelligence that humans exhibit. And so what we were trying to do in the paper was examine some of the assumptions that have been made in the past about what that intelligence looks like, and maybe try to critique them or re-understand them in terms of broader observations about what humans are and are not capable of doing, and then think about the kinds of computations and the kinds of ideas that might underlie, systems that could be intelligent in the way that humans are. So the paper isn't laid out quite like that. We start off, as you say, by articulating this sort of triadic definition of symbols that goes back to a long philosophical tradition, including Peirce and Wittgenstein, as you say. But our general motivation, I think, starts from the behavior, and that's what you see in the title of the paper. So I think the the explain it like I'm five argument is if you look at what humans do and what classical symbol systems do, they're not very similar. Humans exhibit all sorts of ways in which we're biased by the meaning of what we're reasoning about, for instance, in ways that a symbol system that totally dissociates reasoning from the underlying semantics would not. And we think that's not a flaw of human reasoning, but it's actually the reason that we're able to reason so effectively in domains where classical systems it's completely infeasible for them to work. And that's the reason, for instance, that mathematicians are able to have much clearer ideas and reason much more effectively than even a carefully developed symbol system that's designed for mathematical computation. So for example, something like Mathematica. So our argument in the paper then is if we want to have intelligence that's more like this kind of human intelligence that can go beyond classical symbol systems, that can reason in the domains where they're sort of infeasible to use, then we might want to take a more human-like perspective on how our systems should learn. So our systems should learn from the kinds of experiences that humans have, which an especially important part of that experience is sort of social interactions with someone else where you have to coordinate on meaning. So there's a number of psychologists and neuroscientists who have suggested that this process of coordinating on meaning with others is an important part of our cognitive development that leads us to the ability to, for instance, form generalizable abstractions, or even leads us to the ability to form symbols. So that was sort of part of our inspiration for making this argument.
Interesting. And this is one reason why I think both Tim and I so much enjoy talking to the authors, because one can read a paper, and in my case, say I read the paper, but I missed, for some reason or another, a really critical point, which you just raised, which is essentially what you're saying is that the syntactic manipulation, if you will, of the symbols is certainly an important piece of what you can do with symbols. So you're not downplaying the importance of manipulation as far as I can tell. But what you're saying is that the semantic mappings are just as important. And on the one hand, of course, it's obvious. It's like, yeah, of course, symbols have a semantic mapping. Otherwise, what are we even doing with them? Because they're not even icons or not even indexes. They're just these things. They have to be linked to some kind of meaning. But more importantly, the fact that human beings understand the semantic mapping gives them additional power beyond just syntactic manipulation, if I heard you correctly.
But I want to say something a little more fundamental here, which is that the syntax is not important in itself. The syntax doesn't matter. It's only useful insofar as it tells you in the end something about the semantics, right? The only reason that people care about the fact that, for instance, you can apply certain logical operators and get something that's consistent with them is because it tells you something about the semantics of what those propositions mean, let's say.
Oh, sure. Well, I agree with that. But on the other hand, what I'm saying is that syntactic manipulation is extremely powerful. I mean, our ability to abstract and create manipulations, operators, whatever you want to call them, that can even correspond at all to semantic preservation, if you will, or maintaining semantically useful properties. I think that's really at the heart of the unreasonable effectiveness of mathematics, if you will.
Yeah, I think that's a great point, but it all comes down to that semantics and agreeing on what those syntactic operations and operators actually mean, right? And I think that's the distinction that we're highlighting here. And I think that's the reason that humans are able to use these tools. That's what syntactic operations are, right? They're tools that humans have developed.
Yep.
And we've sort of agreed on systems for using them that allow us to do powerful things with them. But I think that syntactic operations are useful as tools. My background is in mathematics, certainly used a lot of logic in my time, and I use, symbolic programming languages every day. But I don't think that those systems are part of intelligence, and that's the important distinction, right? They're useful tools for intelligent systems to use to accomplish our goals, which in the end are about the semantics.
That's a lot like what Richard Feynman probably would have said something similar, because he was always pointing out, look, these are just these tools, you know, they may seem magic, but we just follow the rules and we get useful semantic results, essentially.
Certainly, yeah. And I think it takes an intuition like Feynman's, which is something he was known for, to be able to use the rules effectively in order to find something really new in many cases, right? That's why, you know, being an insightful mathematician or physicist takes a lot that goes beyond the ability to just make logically correct inferences. That's part of why mathematics and physics are so hard. And that, I think, is the part that has been underemphasized in classical approaches to symbol manipulation. It's like, well, what is the part that tells you which inferences are the right ones to think about, and tells you, you know, what is the meaning of the inferences you're making?
Yeah, and in fact, maybe I can put this for my fellow folks that are obsessed with kind of, let's say, computational complexity. I mean, sure, you could write a program that could explore every possible, let's say, application of logical operators to some set of axioms or whatever, but that's this vast space, this combinatorially large, impossible to explore by brute force space. And what I'm taking from what you're saying is that this human semantic intuition acts as this kind of heuristic almost to focus down within that vast space on the things that matter and end up being useful. Is that fair?
That is certainly a part of what we're saying. And so we quote several mathematicians in the paper who are sort of explicitly addressing this argument by some of the classical symbol system advocates that syntactic manipulations are all that matter. And the mathematicians say things like, well, it's actually the ideas behind the manipulations that tell you which sort of things are important. So that's exactly what you're saying about narrowing down the search space, figuring out what the right things to do are. But I think there's something even more fundamental than that here, which is that humans are able to reason about our own reasoning processes. For example, to develop these kinds of symbolic manipulation processes, these syntactic manipulation processes. And I think that having that ability is important as well, and is something that is difficult to achieve if you stick to strictly syntactic manipulations, right? You're sort of assuming the manipulation process that you're going to be using to reason. Whereas by taking a sort of meaning first perspective, you open the possibility of changing those very reasoning processes. And I suspect that this will be important in developing systems that go beyond human intelligence, and quite possibly even in achieving human-like intelligence.
Yeah, I'm finding this really fascinating. We've touched on so many of these ideas when we speak with cognitive scientists, and I really can be convinced that there's a lot to be said here. I mean, it reminds me a lot of discussions we've had with people who study cybernetics and, you know, concepts like embodiment and autopoiesis, and thinking of intelligence as being a process, thinking of it being externalized. Quite often we talk about subjectivity and creativity, and quite often the word that we get to very quickly is the word subjectivity, and in a word, subjectivity is a suitcase word. I don't like that word because I try to unpack what you mean by subjectivity, because you are actually talking about this quite complex, open-ended process. So when we've been speaking about subjectivity recently in respect of symbol use, or certainly when you've been using the word, I think you're using it as a synonym for relativistic and complex, right? Which is to say that it's not so much the subjective. I mean, it could be objective if you like. It's just so complex that we're deciding to use the word subjective. And, you know, when you say it's complex, I think you also mean it's entangled with the state of the interpreters to a certain extent. Would you agree with that interpretation?
I certainly agree with the latter part, the idea that's entangled with the state of the interpreters. I'm not sure to what extent I agree that it could be objective. I mean, I think that almost anything is subjective, in fact. If you take, for example, you could think about the distinction between like Newtonian and Hamiltonian classical mechanics, for example. Either of those is a valid formulation of classical mechanics, and it's sort of subjective which perspective you take. What's the right way you want to describe the system, right? So I think that there's, even in these seemingly objective frameworks, there's a lot of subjectivity in the way we're actually choosing to set up the very system we're reasoning over. And so I think that it's hard for me to say that there is anything that is definitely objective, except for, again, the semantics that's out there in the world. But that's a very specific thing. A lot of the things we talk about in the world are abstractions, which again are subjectively applied on top of that.
Well, this is a point that I often make when I'm kind of, let's say, debating with our friends, which is, for example, in my view, and I think this is pretty well established, all probabilities are conditional. There's absolutely no such thing whatsoever as an objective probability. It's like anybody who ever writes down P of A, that's really just a shortcut for P of A given K. It's like some stuff you assumed, some prior knowledge, and if you forget that there's always this conditionality, you get into all sorts of trouble. I mean, is that a fair analogy here?
Definitely, yeah. And it's like arguments that have been made about the scientific process too, that we're always working within a certain paradigm, and everything that we study is with respect to that paradigm, right? And so...
Well, yeah. And you're kind of pointing at something potentially very deep here that I want to explore. And let me just set this up by making a comment about Sir Arthur Eddington, who actually, he's the one who got me started off on philosophy, because I read his book, The Philosophy of Physical Science. And in there he makes this point, which he's like, look, science is essentially, you're like a fisherman. Say you have a net that has, 2 centimeter by 2 centimeter, holes. You're obviously not going to catch any fish that are only 1 centimeter big. And so you may conclude the ocean only contains, fish larger than, 2 centimeters, etc. That's the nature of subjectivity, in the sense that your tools that you're using are always filtering out, part of the universe. You're kind of missing things. And you said something really interesting to me a few minutes ago, which is that there's this deeper, more fundamental kind of reasoning, I'll just call it for now, that human beings do in this semantic space. And through that, we're able to create symbolic systems that represent, aspects of that or parts of that. And we can create all kinds of math to do things. My question is, and because Eddington made this comment, he's like, we may never be able to get out of this notion of subjectivity. We're always going to be limited in this way. And you're making this point that like we have this deeper, more fundamental semantic reasoning, which we can even reason about and create symbolic systems, but they only capture a part of it. Are we forever stuck that way? Like, is anyone ever going to be able to create a symbolic system that actually completely captures the semantic reasoning that we do?
That's a very interesting question. I'd like to think that it's possible to create a system that captures it, yes. I think that, so when you say create a symbolic system, I think it's important to be clear about what you mean by symbolic there. Like, are you taking a perspective on symbols like we are, sort of like symbols are subjective, and so one part of that symbol system would be the interpretation, or are you taking more of a, physical symbol system hypothesis perspective? That distinction seems important to me regarding how I'm going to answer this question.
Okay, so I maybe I'll ask both at the same time, which is, can we create an abstract symbolic system that can be separated from any physical implementation, that's substrate independent, that captures this semantic reasoning? Or can we only ever create, or is it possible, and or can we create a symbolic system that's connected to some type of physical embodiment that captures this semantic reasoning?
I'm fairly confident that we can create one that's connected to physical embodiment. I'm less confident about the abstract case, but I don't want to completely rule it out, especially because, if you think that humans are some sort of symbol-using system, and you think that you're a physicalist, you think that you could eventually simulate a human with a physics simulator, then you probably think that, at some point this all grounds out, or, if you think that neural networks can do any sort of interesting reasoning, neural networks are really implemented in a classical symbol system in a programming language, right? They're just a set of rules about what you do with numbers and how to combine them to get other numbers out. then you have to think that in some sense, yes, you can implement intelligence in an abstract symbol system. But that might not be the right language to describe the intelligence in an interesting way, in the same sense that, for instance, you can describe an ideal gas as by looking at the small interactions of the particles, but it's much easier and perhaps more informative to describe it at a macro level in an entirely different framework. And so I think that's the distinction I would like to draw there. It's if you think that, intelligent systems can be simulated in computers, which most people probably agree on, then in some sense, yes, it's implementable in a purely abstract symbol system, but that might not be the right language to describe what's really going on there.
It's quite funny. We seem to be talking about strong emergence on every single show lately. But I wanted to talk a little bit about our friend Dr. Walid Saba, because he is a GoFi person and he's a universalist. And I want to understand how your thinking differs from his, because I actually think maybe you don't disagree. So he thinks that we have these so-called universal cognitive templates. He thinks it's one of the most important ideas in cognitive psychology. He's a huge fan of our friend Jerry Fodor. He thinks that language is a system of thought and has primacy for intelligence. I know you don't, Andrew. Of course, it's an open question how much thinking should reside just in the language modality. But back to Walid, he often refers to some of these templates. He gives the example of modus ponens, or the most primitive syllogism, which is to say, if P then Q, P therefore Q. Like a simple example of this is if today is Tuesday, then John will go to work. Today is Tuesday, therefore John will go to work. And he also cites the transitive relation example. So A implies B, B implies C, therefore A implies C. So Walid would argue that these universal cognitive templates correspond to physical reality. They are not invented under any circumstances. He really turns his nose up at that idea. And I have a feeling that you wouldn't disagree with him, right? I mean, for example, even Walid acknowledges that the interpretation or the meaning of a symbol can be subjective. For example, you can interpret the meaning of a painting. This is in stark contrast with the symbolic notion of implication or transitivity. I mean, I have slightly relativistic tendencies myself, by the way, not that I would tell Walid that. I mean, I could be convinced that language is an emergent or partially emergent phenomenon, and I do believe that these universal cognitive templates exist. And would exist if the universe didn't exist. So I can't quite reconcile these two ideas, but I don't think they necessarily are contradictory. Do you?
Yeah, it's an interesting question. I think the way that I prefer to think about it is that these tools like syllogisms are useful descriptions, useful abstractions one can form from the world. They describe patterns that we observe, patterns of inferences that are valid to make, for instance. And that's much like the way that something like Newtonian mechanics describes patterns that are valid in the world under certain regimes. But I wouldn't say that Newtonian mechanics is a fundamental part of the world, really. Certainly in that case, it seems to be more an abstraction that's useful for describing certain regimes of a more complicated system, right? And so I think I don't have a strong philosophical commitment at the moment on where the rules of logic and syllogisms fall, in part because it's not clear to me that we even have I don't know if there's an objective definition of truth that everyone can agree on, right? So to have a notion of logic, you need to agree on what's true, and philosophers actually have a little bit of trouble with even this issue, right? So I think that it's tricky to say, and it's at least practically easier to take the stance that, look, these are valid things that we can say that help us to improve our inferences we can make in the world and to help us to make predictions about what things will and won't happen. And that is a stance you can take without needing to make any philosophical assumption about whether they are themselves an inherent part of the world or just something that's useful to have.
Well, I wonder if and I haven't talked to Walid about this, so I'm really speculating here. I want to make that clear. But I think part of the part of the reason to think about that concern may come into play really with deciding what needs to be encoded as prior knowledge into learning systems. Because, in other words, if there are some things that really can't be statistically learned, and I think Walid makes the point that, look, for example, if modus ponens or whatever other template you consider as being either universal or near universal, or certainly one that you wouldn't want to fail to learn, that if you're trying to get at it by learning, then you always run the risk of either not learning it at all or learning it incorrectly or thinking that it's statistical when in fact it's, much more reliable than that. And so if you don't go ahead and precede an artificial intelligence with some of these basic universal templates that we think are pretty darn reliable, that we're just going to be wasting a lot of parameter space and data, on trying to learn those things, and we might end up not learning them or learning them, incorrectly, I think is maybe the concern there.
Yeah. So I think that's definitely an interesting argument. And of course, it isn't one that's totally resolved or we wouldn't be talking about it. There's 2 points I'd like to make. The first is syllogisms are a great case because if you look at human syllogistic reasoning, it's actually pretty terrible. So your average human off the street, you give them a syllogism and their assessment of whether it leads to, this is a classic study from like the 70s, their assessment of whether a syllogism forms a valid argument, including the conclusion, is hugely biased by whether the conclusion fits within their existing belief structure. So these cognitive psychologists gave these arguments, syllogistic arguments, with conclusions that were like, all people who are scientists are educated versus all people who are educated are scientists. So you sort of have like a mirror version of the proposition, where one version is somewhat plausible to people and the other version seems pretty unlikely, right? And what they found was that you can, just take the logical argument that would lead to this conclusion, and you can just flip the terms around so that you get either of these conclusions. And people's assessment of the validity of that argument is hugely affected by those conclusions. And you can see these sorts of like patterns of the content affecting reasoning and all sorts of logical tasks too, like the Wason selection task, which is a slightly different logical reasoning task. I mean, there's debate about how you should interpret these things, of course, and a lot may depend on who the particular people are, what their educational backgrounds are, and what the precise instructions they're given are. But I think that it's interesting to ask, well, if you think syllogisms are so fundamental that they have to be encoded into intelligence, what predictions would you make about human syllogistic reasoning?
Well, Andrew, are you suggesting that humans are not entirely rational actors?
I think I am, yeah.
Well, look, I just want to jump in for a sec, because a lot of this, and I know I say this often, but a lot of times people are just insufficiently Darwinian when they analyze these situations, because you have to remember the human individual is embedded in a context of life in general and evolution of the species and the gene pool and et cetera. So the fact that individual people have encoded or programmed into them, pre-programmed really, these kind of errors and things like that, doesn't mean that the overall process itself isn't conducting a very rational, exploration, if you will. So I think we shouldn't read too much into things like that. It's like, for example, simple example, ants. Okay, ants go and follow pheromone trails that are left down by other ants. Okay, but they also occasionally fail to do that. They have errors. They go off in some random direction. But that's actually essential for the algorithm to discover new resources. If you're always just following the path that's been laid down by others, you're not going to explore, right? It's like this exploration versus exploitation trade-off. And a lot of this same type of, analysis applies to some of these things. Like, oh my God, people aren't perfectly syllogistic. Well, there's reasons for that, right? A lot of reasons for that. So let's just keep that in mind before we bash, individual human rationality too much.
So I think that's a great point. And it actually leads into the second point I wanted to make from this, which is that often what I see when you attempt to build in something like syllogistic reasoning is that you limit the things that your system can consider too strongly. And my contention is that is why you see that classical symbol systems say work really well when you have a perfectly symbolically structured domain that's small enough that you can run reasonable inferences and don't scale to solving any sort of real world problems. It's a slight exaggeration, but at least don't scale to that without a human having to come there with our knowledge of the meanings, with our ability, as you're agreeing with me, to go beyond that kind of strict logical reasoning and to use something else to reason. And so that's why I think that trying to build these sorts of structures into our intelligence is the wrong approach. Instead, we should teach our intelligence to use these processes to reason in the same way that humans can learn how to use logical reasoning, can learn how to use mathematics to achieve our goals, but it's not a fundamental part of our intelligence. It's a tool that we constructed together and that we can also share with our artificial intelligences and continue to construct together. That would be my argument.
This is such a difficult one. I feel like this is one of the key philosophical questions that we need to get over. Because as you say, as soon as you do come up with a model, you're excluding a lot of richness from the analysis. You're kind of chopping off many aspects of the system. And a lot of it comes down to primacy. Like in the case of Walid, is language the primacy to intelligence? And maybe we should have the complete opposite view. But it plays with my intuitions, Andrew, because I really think that mathematics is discovered. I don't think it's invented. Whereas with language, my intuitions aren't quite as strong as they are with mathematics. And also, like nativists like Chomsky, they think that we have a lot of this apparatus built in. Also, part of my mind is saying to me, you would say that, wouldn't you? Coming from DeepMind, with huge investments in the connectionist way of thinking, it doesn't surprise me that you would make that argument. And it also this whole thing about maybe both things could be true. I genuinely think that universal cognitive templates exist, and I don't think it's a dichotomy between these things existing and having strong emergent phenomena in the universe.
Yeah. I think that you're right. It's probably not a dichotomy. Let me say something about language, I guess, since that's come up a lot. And it's actually an interest of mine more generally. I think that language plays a very important role in human cognition, undoubtedly. And I think that it's something that's very important for artificial intelligence researchers to consider, because I think it gives us ways of, it's sort of a pathway into creating abstractions, right? That's what language really allows us to do, is it allows us to take a bunch of different things and link them all together with a single label. And that's a starting point, I think, for building some of the symbolic tools that we have. So I think it's very important. That, again, doesn't rule out the possibility that it's not a fundamental built-in part of our cognition, but it's culturally constructed. And I think it's a bit messy with things like language. Like, clearly, in some sense, language is built into humans by evolution, in the sense that, like, our voice box and our throat is adapted to speaking in a way that the throats of monkeys or our closely related primates isn't, right? So clearly there is some evolutionary adaptation to using language. I wouldn't deny that, but does the mental part of that adaptation correspond to something like merge, which I guess is Chomsky's most recent version of this, last time I checked, or some sort of basic recursion principle or something? That I'm less sure about. And again, if you look at how well people do with something like very deeply nested recursive clauses, it's, maybe not as well as I would hope from a system that had recursion built in.
Interesting. But yeah, this dichotomy is invention versus discovery, though, isn't it? And usually when people say invention, what they actually mean is emergence. We spoke to David Chalmers yesterday, actually, and he said that, he lamented that emergence is the most abused term in science, and we got into quite an interesting discussion. But this is so fundamental, though, because we're trying to run a podcast here on AI, and it just seems like an infinite regress. We're going back to philosophical principles, And I loved your conversation on the Generally Intelligent podcast. By the way, folks, you should go and subscribe to that. It's probably the only other podcast similar to our one. But, you were saying that there's a variety of causal mechanisms between language, the world, and cognition. And all of these cognitive psychologists, they can't actually agree on where to draw the arrows on that diagram. So does language have primacy? Does the world have primacy? How do we even start when we don't know something as fundamental as that?
Yeah, I mean, it's a tough question. I think this is an old problem in science where you want to reason about a long-term process like evolution. And it's not like you can go out and run the experiment and be like, well, let's causally manipulate language in the history of human evolution and then see what happens, right? And so I don't have an answer for you on that, honestly. I don't know where to start. Maybe the right place to go is just to have different people take different perspectives on this, see what they develop, and then see where we end up. I mean, I think that's kind of what we're doing anyway, but it might be the best we can do under the circumstances.
Well, it is kind of what we're doing, but there's this effect of the hardware lottery and things like that, right? Which is once resources get invested in a certain direction, then of course more flow there. And so while we may eventually get to where we want to go, that can actually slow down the process as well by focusing too much resources down a path. And this gets to what I wanted to ask you, which is whenever I get excited about some set of ideas, like say what we've been talking about, then I start thinking, great, I want to go build that. Okay, so now I want to go build something that embodies, Andrew's ideas and really kind of pushes them forward. Well, I asked you earlier about this kind of, is it possible to create an abstracted symbolic system that can capture this or not? Because it actually has an important, effect on the choice you're going to make here. It's like, if you believe it's possible to create a substrate independent, representation of, say, this deeper semantic reasoning, well, then you can go do it now on today's existing computational platforms and that sort of thing. Potentially, you can write some code that can do it. If, on the other hand, that's maybe not quite as likely, that there could be some type of substrate dependence, it might get you off thinking, maybe I need an analog computer. Maybe I need to go start trying to build chips or use the newer, analog chips and play around with them more. I mean, do you have an opinion on there? Suppose you were today, there's some researcher out there that says, love your ideas. I want to start working on them right now. Would you direct them down the current hardware lottery path of just, go write some, code and PyTorch or whatever and off you go? Or would you direct them down towards some more, speculative or less common, less taken, like analog computing or something?
Wow, that's a very interesting question. I mean, I think part of my point with saying that, in principle, it would be implementable on a discrete abstract symbolic system if you could simulate a human or whatever, is to say that, yeah, it might be possible, but you might need an insane amount of, let's say, processing power and memory and so on in order to do so. And that wouldn't be the practical way to do it, in the same way that, for instance, if you take something like the difference between classical and quantum computers and prime factorization, it's possible for them both to do this computation, but in one case it's just, not feasible with our current standards, and in one case it might be feasible with a relatively small amount of technological development. So I think I'm currently betting on something that's built within computers, to be computers that we have now, to be able to achieve something more like human intelligence. Not saying that we're there yet, but I think that it's important that people keep working on these alternative approaches, keep developing things like analog computing, neuromorphic computing, spiking networks, all the things that people are considering that don't fit nicely necessarily within the classical computer science paradigm, because I certainly don't have the answers about what is the right way to think about these things, and sometimes we don't really know the right way until we see it in retrospect.
Okay. And if you are betting, suppose you're somebody who decides to continue betting on the current computational paradigms, let's say, I think I read, or I think I gleaned from your paper, perhaps you might advocate the need for more open systems where modules are kind of interacting and developing the capabilities to create these constructed, symbolic systems, if you will. Does that lean us towards something like OpenCog, like Ben Goertzel's kind of idea that you need to have almost an ecosystem where AIs kind of, or potential AIs, let's say nascent AIs, can kind of compete with each other for resources, and that they survive and they become useful to one another, and that's actually like an important overlay to have on top of a computational system to have it grow, if you will, or evolve, general intelligence.
It's going to be important to think about the training paradigms, definitely. I'm not sure how I feel about that one in particular. So one of the things that we tried to advocate for in the symbolic behavior paper, and this may be less true in the more recent version of the paper than in the earlier one, which had like 3 times as many words in it and was correspondingly much harder to read. Instead of having a bunch of AIs that are interacting with each other, it's going to be more useful and better for our ultimate goals to have them interacting with humans, or at least in some ways embedded in human culture, right? For several reasons. So one thing is, I think that whatever your perspective is on these fundamental philosophical issues, you can agree that humans have culturally developed a bunch of things that are useful tools that we would want our agents to know about. And the second point is that if we have artificial intelligence, we're going to want to be able to interact with it as humans to get it to do things, right? Why do we want to have artificial intelligence? Well, it's so we can ask it to help us out with things in the world. And so we want our artificial intelligence to be human compatible in that way. And I suspect that if you were able to go off and run an evolution process in some completely separate world, I'm not sure you would get something that's particularly human compatible. I think having that immersion in human culture is going to be important for achieving that, I suspect.
Otherwise, I guess it's kind of like you'll get a AI version of Lord of the Flies, like it's off on its little island there developing something that you really wouldn't want to be a part of.
Exactly. Yeah. And I think that, particularly this competitive sort of, a competitive cost function can lend itself to developing very nasty behaviors that you wouldn't necessarily want to have your AI learning. Social behavior is somewhat common among animals, but it's not that common, and there's a lot of really nasty behavior out there.
I'm really intrigued by something you said, because our culture, it's a bit like a computer program, and you could say it's emerged. And it's complex, isn't it? And it's distributed, and it might be, you might say it's undecidable, and it's also hard to recreate it, because when we were talking about the various arguments from simulation, or even if we had a conversation with Wolfram, for example, there's always this notion of, well, how do I recreate the thing that we've already got, without starting again from scratch, right? Because of the irreducibility argument and so on. So I'm really interested by what you're saying, because if we do want to have AI which is explainable and aligned to our culture, then what do we do? So do we make them interact in some kind of objective way? Can you give us your thought process?
Yeah. So I don't think this is a solved problem either, but one sort of research program that we point to in the paper, not coincidentally because many of the authors are involved in that, is this sort of paradigm that's laid out in this paper on imitating interactive intelligence at DeepMind, where basically we have recorded a large data set of human-human interactions in a simulated environment that are involving language. So one human is instructing another human to do something in the world. And one thing you can think about, at least, is using that as a starting place for learning, using that as a part of the learning process, trying to get a system that sort of, in some sense, is shaped by that human-human interaction, and ultimately even it would be nice to have a system that's shaped by system-human interactions once it's developed a little bit more. With the efficiency of the systems we have now, I think that would be a bit slower to develop an AI from scratch like that. But you could imagine starting from a data set of human-human interactions, moving to having human online interaction, for instance. That's one of the points we make in the paper.
Yeah, I guess you're going to have a lot of people worrying out there because we've already seen what's happened when we try to even just train AIs on the totality of human-human interaction. It goes out there and it finds 4chan and every other dark corner of the web and kind of learns, some of our worst traits as well. And I myself at one time did a lot of online gaming and, saw quite a bit of, behaviors that we wouldn't want to replicate, in an AI. So it's an interesting quandary. Like, how do you train an AI that's both compatible with human behavior and learns from human behavior, and yet that, at least I would hope, can in some ways be better or, more positive, a more positive influence on the world than just yet more people or more versions of people that even learn some of the worst things about what people do.
Yeah, it's a very interesting question. We're now starting to get into like Plato, Socrates stuff about what is virtue and can it be taught and so on. But I think I don't have the full answer. I mean, the data set that I'm talking about has the advantage that it was not just scraped off the internet. It was relatively carefully collected from people who were intentionally trying to create data for this purpose. And so in that sense, it hopefully doesn't have the worst of 4chan at least, but it still might not be the perfect thing. And of course, it is, at some level, it's going to be important for a system to understand all aspects of human behavior, I think, in order to be better, right? And to be able to handle all the situations that it finds itself in the world. And from that perspective, I think we need to think carefully about, well, how would you expose an agent to, a problem that we kind of solve with children as well. Like, how do you expose something to all the horrible stuff that's out there in the world in such a way that hopefully it makes the world a better place? I think that is a problem that we're going to have to think a lot about. But I do think, again, having humans in the loop there will be very important in helping to, shape what behaviors are considered acceptable. Then you have to get into all these questions of, well, acceptable to whom and who sets the standards and so on. That's,
Agreed.
Yeah, lots of thorny issues here.
Without going too far down the ethics discussion, do you think that, because I like to think of the bad parts of human behavior being a bit like a storm, like the storm on Jupiter. And I just wondered whether you thought that we needed to have some of those storms in order to bring out some of the other aspects of human behavior. And I guess an extension question is, when we spoke to David Chalmers, we asked him the question, what makes an interesting simulation? Is it the universe mostly filled with gas clouds, or as it is now with just a tiny sliver of intelligence, just dotted in the universe? And who are we to say what's good and what's bad? Do you know what I mean? What's your take?
Yeah, that's a very interesting question. I think that we're all sort of fumbling along in this, I guess. And so, yes, I think that our intelligence is quite limited in a lot of ways and may not be, like you're saying at the end, may not be we certainly don't know all there is to know about being ethical and so on. And every 50 years or so, we've kind of refined our conceptions of this, I would say. At least recently. So I think that this is actually a point that we tried to make in the earlier paper that probably got cut from this shorter version. But I think that it's important for our artificial intelligence systems to be able to develop a framework of ethics, and more generally, frameworks of knowledge that have a kind of epistemic humility, in the sense that they accept the possibility that the very foundations that they're building on might be a little bit shaky and should be subject to possibly being reconsidered at some point, in the same way that we've really fundamentally rethought some of our ethical foundations at various times over recent history. And so I actually think that this is a place where one has to be very careful if one develops, like, let's say, a strict rule-based system for reasoning. You want to make that system amenable to change and possibly to developing better systems for better ethical systems, let's say, while at the same time keeping it human aligned. And I think that's a very challenging problem, but I'm concerned that too strict a rule-based definition of ethics might lead us into a quagmire where our systems just fundamentally are not keeping up with the way that our notions of ethics evolve.
AI ethics is a huge kind of thing right now. And this is maybe even perhaps a simpler aspect of what we've been talking about, which is, okay, look, let's forget about trying to figure out the next generation of AIs, just with the current AIs that we have, some neural network trained to diagnose diseases or whatever, is it fair? Is it ethical? And people are embarked on the very process, at least half of them or more, are embarked on the very process, which maybe you're slightly warning about there, which is they're trying to find rules, to determine whether or not these AIs are fair, or quantitative measures of how ethical they are. I mean, is this just a flawed path for us to be going down?
I definitely don't want to say it's a flawed path. I mean, I think it's very important to quantitatively assess these things. I think that where you get into dangerous territory is if you think that the endpoint is going to be, well, I slap a rule on top of the system that makes it fair, let's say. That's where you might start to run into challenges as our notion of fairness evolves, for instance, or if we want our systems to be able to develop notions of fairness, or to help us with that development, right? To help us figure out what is ethically right.
Right. So it's almost like the way humans have solved this problem is we have judges. We recognize that you need to have some baseline rules in place, but they're never going to exactly demarcate the boundary. There's a degree of vagueness there. And so we have to have agents that can look at both sides, weigh the options. Hopefully they're fair and impartial, and then they come up with a situation specific, judgment. So I guess for the AI folks out there, I would say probably what we should advocate for is some basic sets of rules, but at the end of the day, you need to have the capability for human judgment, to enter the picture.
Just to relate this to our arguments, again, our core arguments, we're arguing that what you need is systems that can sort of come to conventional agreements about meanings. And I would argue that a lot of our legal systems, democracy and juries and so on, are all about coming to agree on what is the right thing in a particular situation. That's a very fundamentally important process in our legal system. And that's a process we'd like our systems to be able to engage with us in, rather than just having a hard decision. This is fair. This is not fair.
This is so interesting. Because if you think about it, it's very, very complex again. So we were talking about the program of our culture being a distributed, it's a bit nebulous, it's amorphous, the boundary is very vague and so on. And you were just saying that we coalesce. And if we're having a relativistic discussion as well, we might say that, okay, well, we might think of accepted ways of doing things as being centroids, and we might think of how those clusters of activity are related to each other. And we might, because I know you're interested in explanations and using language, we might come up with abstract motifs to describe various aspects of these systems. But this is the fundamental problem we have with AI. And as I said, it could be very heterogeneous. But anyway, I must get on to the next point, which is, and I'm sorry to ask you this question, but everyone in the audience wants to know the answer to this. We interviewed Yazaman Rezegi last week, and she did some really interesting research. which showed a linear correlation between the term frequency in the training data set and the accuracy of arithmetic operations on large language models. I'm not sure if you're familiar with that work, but it at least seemed to show that the models were not really reasoning. They were just kind of memorizing the data set. And we already know that a lot of large language models, that their performance is largely dependent on the corpus and how the corpus is curated. And a lot of the large tech companies, not DeepMind, of course, are trying to give the impression, at least, that these models are doing reasoning, which, and by reasoning, we mean basically extrapolating out of the training range. What's your take on it?
So I think it's great that people are doing scientific work on this, because I think that this is a very interesting scientific question. And as a cognitive psychologist, the thing I want to ask is, well, can we do some more carefully controlled experiments with the, where we really lay out a set of training data and we see what sort of extrapolation that gives rise to, or non-extrapolation. I think that the arithmetic results are very interesting. I do have concerns about arithmetic problems in particular with regards to relatively low-level issues like the tokenizer, because a lot of these models don't tokenize numbers in a way that would make sense to us humans at all. Like, it might break a number like 184 up into like 18.4 or something. Anyway, so there's a lot of weird issues there that might give rise to that might make it very hard for the system to learn about arithmetic, that I don't think are really fundamentally about arithmetic or these systems' ability to do them, but are rather about the fact that these systems were built for processing language. Their tokenizers were designed to work well for processing language, and maybe if you want them to do something like arithmetic, that's not the perfect way to chop up their input, right? So I think that there are some potential caveats there. I think that there's been a lot of exploration of what these models can and can't do that paints a sort of varied picture. So to give you a couple of examples, I mean, there's this open source or a collaborative data set called BenG. I'm not sure if you're familiar with it, but a group of researchers from Google Brain crowdsourced about 200 tasks that were explicitly sourced with the intention that they would be hard for language models. So the big part of BenG stands for Beyond the Imitation Game benchmark. So if you look at these tasks, they involve all sorts of things like reasoning about metaphors, or doing arithmetic reasoning, or recognizing, things that are written out in ASCII art or something like that. So there's a very wide range of stuff in there that people thought would be hard for language models. And I think that there's interesting patterns of results on these tasks. I mean, some things really do seem to be hard. Some things seem easier than you think. Some things are completely at chance, even with the best models. So I think there's, those cases are potentially an interesting case to look at too when you're considering this stuff. The second thing I want to bring up is there's this very nice paper from a year ago or so that I think we referenced in the symbolic behaviour paper, where someone took a pre-trained language model and taught it long division with a few hundred examples, but gave it very detailed traces of what those problems should, how to do the long division process, and allowed it to write on an external scratch pad. So it was able to sort of write down a token and then look back at that token later, like a kid might do if they were doing a long division problem. And that system was able to generalize to other long division problems quite well, as I understand it. And I think that's an interesting, slightly different case study, right? It's like, well, okay, so a model with a weird tokenizer trained on language modeling doesn't do arithmetic reasoning perfectly, but how do humans learn how to do arithmetic? Someone actually sits down and teaches them and walks them through the steps, right? And maybe they need to write things down on paper while they're learning how to do it. And maybe they learn with some sort of external aids to understand counting and so on. They learn about counting before they learn about arithmetic. So I think there's a wide constellation of things that are relevant to human reasoning, things like the external aids we have, like things that we can write on, things like the educational process we have that teaches us certain patterns of reasoning. I'm not surprised when a model that's trained on next token prediction doesn't do all these aspects of reasoning perfectly. And I'm kind of surprised when people are surprised by that, right? But that doesn't necessarily mean there's anything wrong with, let's say, the class of transformers as models per se. It might just mean, well, there's some aspects of what it takes to get intelligence that are not covered yet by the things we've been training them on.
Yeah, I have to challenge on one thing here, which is the point of Yasmin's paper wasn't that these models weren't doing arithmetic perfectly. It was that they were failing in a very particular way that was highly correlated, with the corpus. When you're trying to judge intelligence, it's even more important actually to look at the ways in which an agent fails than the ways in which it succeeds.
Totally. I absolutely agree with that. Just to get back to the correlated with the corpus thing, though, that's also part of how the tokenization gets constructed, right? Is what is the occurrence frequency of these particular pieces of the text corpus, right? And so you could interpret that correlation in different ways. And so I haven't read this paper. It's on my reading list, but I haven't gotten to it yet. But I'm interested to see if they looked at things like, well, is it correlated with which particular tokens are, is that correlation mediated by the tokenization, for instance? I do think that you will see frequency biases in these models, though certainly trained on next word prediction, but even in general. But to bring it back to the human case, again, we also see that humans are very content biased reasoners. So I mentioned this task called the Wason selection task earlier, which is a sort of logical inference task where basically the goal is you tell a participant a rule like, here's a set of some cards. If a card has an even number on the front, that should have a vowel on the other side. And then you show them two cards that have the numbers one card with the number one card with the number two, a card with the letter A and a card with the letter B. And you ask them, which cards do you have to flip over to check if the rule is being followed? And people are not particularly good at this. They mix up the converse and the contrapositive. And so they're not good at getting if it's an even number, then it should have a vowel on the other side. Therefore, to check whether whether this rule is being violated, we need to flip over the one that doesn't have a vowel, because that's what would make that proposition not true, right? The interesting finding is that you can take this same logical situation and you can put it into a much more familiar situation for people by saying, well, these cards have people's ages and what they're drinking. And if the number on them is, so if they're drinking alcohol, then the number must be over 21, right? The age must be over 21. And then people are basically perfect at solving this task, right? So I think that people's reasoning is also biased by how familiar the particular things we're reasoning about are. And that may be one of the, again, that may be a feature as well as a bug, because it allows us to do well in the situations that are most common. So I think that humans can escape some of these biases. But again, I think that's something that we have to do through education, through being trained to reason more logically, to use these rules in a systematic way. And I think that's something that we can also train our models to do under appropriate circumstances, but I'm not sure that next token prediction is the perfect circumstance for that.
Indeed. Very quick final question. If I trained an Andrew robot, let's imagine I had the simulator of the world, and by the way, that reminded me, I was going to ask you an interesting question earlier. In the Matrix, the architect, the first version of the Matrix was a perfect simulation, wasn't it? And there were no bad people in it. But anyway, I'm having a chat with the architect. I've done a whole bunch of simulations. I've got an Andrew robot, and Andrew now can respond to any situation you're likely to face, for the next 5 days. And I compress all of that hash table into something called a neural network. And no one has any idea that it's not the real Andrew. They just, they can't distinguish. Would you think that Andrew was intelligent?
I think that's a great question. I don't think that it has to be intelligent. Like I do feel like a perfect lookup table is not intelligent. I feel like intelligence is about adapting to new situations. Definitely. So no, I wouldn't say that system is intelligent necessarily.
And
Fascinating.
and let's suppose it's not intelligent. Let's suppose it was intelligent. Maybe we modified it a bit so you decided it was intelligent. Would it be conscious?
Oh, I don't talk about consciousness. I don't want to get into that. I don't think we have a good definition.
It's all about that little bit extra. Yes, indeed. Well, Andrew, Dr. Lampinen, I should say, from DeepMind, it's been an absolute honor. Thank you so much for joining us today.
Thank you so much for having me. It was a lot of fun.
Remember to like, comment, and subscribe, and we will see you back next week.